In this video, let's look at a couple more example problems where we are solving similar triangles. Or in other words, we're essentially finding a missing side length when we know that two triangles are similar to each other. And since we know that the triangles are similar, we know that they have three sets of correspondingly equal angles and their side lengths are proportional to each other. And we can use that fact to determine what this missing side is. And remember that when two triangles are proportional, that just means that the bigger one is a scaled version of the smaller one. Or in other words, to go from the smaller triangle to the bigger one, we are multiplying each of these side lengths by the same number. So if we can figure out what we're multiplying by, let's say to go from the small side in this triangle to the small one here, then we can use that idea to figure out this missing side length here. And you might be able to figure this out quickly, but let's set it up using ratio so that we can look at it in a more formal way for when the problems are slightly more difficult. And we want to compare the corresponding sides. So let's start with the smallest side on each of the triangles. And we'll look at their ratio, their quotient. We'll take the bigger one and divide by the smaller one. And you can see this is equal to 3. And you can also notice that if we looked at, let's say, the middle side lengths, that if we took the bigger one and divided by the smaller one, it is also equal to 3. So to go from the smaller triangle to the bigger triangle, we are taking each of the side lengths and multiplying by 3, which means that we're doing this here as well. We're taking t and we are multiplying it by 3 to get 19.5. Or we could look at it in reverse. To go from the bigger one to the smaller one, let's say for the smallest sides, we are taking 12 and we are dividing by 3 to get back to 4. So if we take 19.5 and we divide it by 3, we will get back t. But let's set this up as an equation. We are taking t, this missing side length. We are multiplying it by the proportionality constant, which we figured out was 3. And that will give us the big side here, which is 19.5. And if we divide both sides by 3, we can use a calculator for this, or 3 goes into 19 6 whole times. There's 1 left over, so we'd have 3 going into 15, which would be 5, and you would carry the decimal down. So t is 6.5, and again, you can check this with your calculator. And remember, we could have also set up an equation to solve for t, where we said that, let's say, comparing the smaller sides, this 12 over 4, this is equal to the bigger side, the ratio of the bigger sides, 19.5 over t, and then solve this equation for t. Multiply each side by t, multiply each side by 4, we get 12t is equal to 4 times 19.5, divide both sides by 12, and after everything simplifies, we would still find that t is 6.5. So you can either figure out that proportionality constant, or you can set up this equation involving the ratios of the corresponding sides. But the answer for this one, we can put 6.5 into our box. And let's do just one more of these, where again, we're told that we have two similar triangles. We have FGH and ABC, and we need to figure out what this missing side is here. Now, when they're whole numbers, sometimes you can figure it out fairly quickly. Notice for the biggest side lengths, we know GF and BA correspond to each other because we have GF and BA here. The order in which the similarity is written matters. It tells us which side lengths actually correspond to each other, or which angles correspond to each other. So H and C, these would be equal angles. And notice, to go from the smaller triangle to the bigger triangle, that we are multiplying by 2. And you can see that here as well. We're starting at 7, and we're going to 14, which is multiplication by 2, which means that if we start at 6 and we carry out that same multiplication, we're essentially scaling this triangle, we're multiplying all the side lengths by the same number, we would find that x is 12. And if you wanted, you could have also set up ratios. Looking at the bigger sides, we have 18 over 9, and we know that this is equal to the ratio of the smallest side here, which we know as x, divided by the smallest side here, which is 6. This is 2, and multiply each side by 6. We get 6 times 2 is x, which of course is 12. And it really just depends if the numbers are difficult or not. Sometimes it's not obvious what you're multiplying by or dividing by if you go in reverse, but sometimes it is. So it really just depends how difficult it is to compute those ratios. Sometimes it's very beneficial to actually set up an equation and then solve for that missing variable. But in either case, x is equal to 12 here.